Okay, so we're talking about the arc now. This arc right here, how are we going to measure that? Well, we split the circle up into 360 degrees, not just here for angles, but also the arc of the circle we divide up into 360 degrees, just to make things simple, I hope. If this is 70 360ths of the circle right here, then what do you think about the arc? How many 360ths of it, the whole thing would it be? Yeah, 70 degrees. So the measure of arc AC, that's the way we say it, is 70 degrees. And this is called, right here, this is called a central angle. And the measure of the central angle and the measure of the intercepted arc, they always have the same measure, which makes life pretty good, right? Okay. I'm also going to talk to you about a minor arc and a major arc. Okay, so the minor arc in this case is AC. Sometimes people get a little confused when they first learn about circles, because you'll say arc AC and they'll say, well, are you talking about this arc right here, or are you talking about arc AC this way? See what I'm talking about? But AC is a minor arc. It's less than 180 degrees. And you can tell because I only use 2 points to name it. Major arcs, when I'm talking about all the way around like this, I would talk about arc ADC. So that would be a major arc. And by the way, we do know what its measure is. It's 360 subtract 70, isn't it? So 290. 290 degrees. So you have a minor arc right here, and it has the same measure as this angle right here. And then you have our major arc coming around like that. So whenever you see something like this, it's always the shortest distance around the circle. Does that make sense? From A to C or from C to A. Pretty basic stuff. What about a diameter? Let's look at something with a diameter here. Well, that was fabulous right there. Can you try that again? Okay, let's draw a diameter in here. We'll call this circle X, and I'll call this Y and Z. Can you all see arc YZ? What was that, Logan? Which one? Which one are you talking about? Are you talking about this arc, or are we talking about this arc down here? That would be, you don't really have a minor or a major arc here, do you? Michael, what are you saying? Well,
imagine if you're like building something with construction and you want to make like the first half different than the second half.
Yeah. Okay. And you guys know what the measure of this angle right here is, don't you? Yeah. It's a straight angle, isn't it? 180.
The baseball team
so 180, right? 180 down here. So yeah, and I think we just want to understand a semicircle. Oops. So a semicircle isn't part of a circle. It's not some random thing of a circle. It's half a circle. Whenever we talk about a semicircle, we're talking about exactly half of it, 180 degrees. Okay, 180 degrees here, 180 degree arc. That's what we're talking about. And if we wanted to be specific about which one of these two arcs we were talking about, we'd have to have another point somewhere. So we could say arc YWZ or something like that to name that. All right, that's pretty simple. Hey, what if I give you this and I tell you the measure of this angle is 45 degrees? Can you tell me the measure of arc YQ? Yeah, 45 degrees. Can you tell me the measure of arc QZ? Yeah, Creek got it, 135. Just, it's 180, subtract the 45, right? Okay. Can you tell me the measure of arc YQZ? Yeah, it's 180. It's a semicircle, isn't it? Here, this is the kind of problems you're going to get today. They're super rough. That arc's 110, that one's 80, that one's 40. You think you could figure out the missing arc?
Yeah.
What they gonna add up to? Yeah, it's not a brain cramper today, is it? Okay, you got it. You can tell me what the measure of the arc is, whatever the central angle is. That's a word you got to know. Central angle. Okay, look down at the bottom of page 539 for me, will you? Everybody got the measure of arc TQ? Say it. 120. What about QR? What about SQ? Ooh, made you think, didn't I? Okay, so what's SR? Arc SR. 100? So that's 360 minus, subtract the 80, subtract the 120, subtract the other 60. So that's 100. Okay. So then arc SQ, its measures 100, and that would make SQ 160? Okay. All right, so that's basically the deal with the central angles, the arcs, things like that, just so you can read them. So now let's talk about congruent circles. Let me just draw a couple circles here for you. Okay, would you say that those two circles are congruent?
No.
They're both circles. Okay, are they similar?
Yes.
Okay, so would you say all circles are similar?
Yes.
I'm gonna have to go with that one. So these two circles are not congruent. Why not?
Because they don't have the same diameter or circumference.
Okay, and keep going down from there. Diameter, yeah, radius. So since we define a circle as all the points that are equidistant from a certain point, we really define it by its radius. So these two circles, their radii are not congruent, are they? Okay, and so the circles are not congruent. Now, here's something I got to make clear to you, which is, I don't know, it's a little weird. It's kind of like you guys on a Monday. A little weird. Okay, so I want to know about arc AB and arc XY. What is the measure of arc AB? 120 degrees. Okay. Central angle is 120. It's 120. All right. What about the measure of arc XY? 120 degrees. All right. So, would you say that the measure of arc AB and XY are congruent?
No, but technically.
No, but technically.
They're similar, but they're not congruent.
Okay, so here's what's weird. Do they have the same measure?
Yeah.
Yeah, I think I would agree. I would think the measure of AB is equal to the measure of arc, XY. Their measures are the same. However, I don't think they're congruent. I don't think that we could say arc AB is congruent to arc XY, but doesn't congruent mean that they have the same measure? Isn't that how we defined congruent before? Two things that have, they're different things, but they have the same measure. We didn't want to say they're equal. So let's think about congruent for a minute again. We had a segment. This is how we started out with congruent. Got another segment. This one's 10 inches long. It's called AB. This one's XY. It's also 10 inches long. And we would say AB, like this, that's the measure of AB, right, is equal to XY because their measures are equal. They're both 10. But we never said segment AB is equal to segment XY because they're two different segments, and equal means they're the same thing, right? Okay, so now, and every single time we've looked at anything, congruent, if they're congruent, that means they have the same measure. And then here, we have two arcs that have the same measure, but they're not congruent. That's odd, isn't it? Doesn't that go against everything we've kind of looked at this year? And I need you to comprehend what's going on here a little bit. So let's turn to page 540 for a minute. So congruent circles. Two circles are congruent if and only if a rigid motion or composition of rigid motions maps one onto the other. That seems like a complicated way to say it. What if they have the same radius? What if their radiuses have the same measure? Okay, all right.
Students, can I have your attention, please? If you have Coach Jeff's PE class, you need to meet in his classroom. If you have Coach Jeff's PE classes, you need to meet in his classroom today.
Okay, so the bell's going to ring. We've got a short day today. Your homework is to read page 540 and 541 and be ready for a quiz when you walk into class tomorrow.